All right, today's discussion is with Craig Hill and Stas Kolenikov, two of the editors responsible for the book Big Data Meets Survey Science, a collection of innovative methods, which came as a result of the first Big Surv conference in 2018. So thank you, Craig and Stas, for joining us at Book Club 2.0. I am Martha McRoy. I'm the program chair for DC-AAPOR and your host for this session. DC-AAPOR's Book Club 2.0 series couldn't be possible without the rest of the DC-AAPOR program committee, which includes Samantha Goldstein, Zoe Paget, Sarah Spell, Martha Stapleton, and Amanda Wilmot. So if this is your first time coming to Book Club 2.0, welcome. Our goal for this series is to provide a fun and interactive forum to review and discuss the latest publications in the field of survey methodology and public opinion research, and be given the opportunity to engage directly with those responsible for the book. Craig and Stas will present some highlights and key insights from the book, and during that part, please mute your microphones, but feel free to post thoughts or questions in the chat box as they come up, which we'll be monitoring throughout the session. Then we'll open up the floor for discussion. I encourage you to please feel free to turn on your cameras and ask your questions or provide feedback directly. Also, feel free to contribute to reactions and comments to each other and with Craig and Stas. And remember, some of the most helpful insights often come from more unstructured conversations. So to the extent we can mimic that on a Zoom call, let's try it. At the end of the hour, I'm going to announce the name of the lucky DC-AAPOR member who's going to win a copy of this session's book. So a big thank you to the DC-AAPOR Executive Council for providing the opportunity to own the books that we feature in the sessions. It's now my pleasure to introduce our guests. So Dr. Craig Hill is the Senior Vice President of RTI International's Social, Statistical, and Environmental Sciences Unit, with more than 35 years of experience in social science research, in which he's directed research projects, both large and small, for a wide variety of federal, academic, and commercial clients. Dr. Hill has published and presented more than 50 papers on topics as diverse as hospital ranking methodology, healthcare delivery and access, survey interviewer fraud, and new technology for social science research. In his current role, he has direct management authority and responsibility for a portfolio of more than 350 studies and more than 1,100 professional staff. Dr. Stas Kolenikov is a principal statistician at NORC, where he works on statistical and data science problems in survey design, data collection, and analysis. He's an active member of AAPOR, where he contributes to several committees and is one of the associate editors at POQ. He is also active in the American Statistical Association, where he's held a number of roles for the Survey Research Method section and for the Text Analysis Interest Group. The ASA just recently recognized him as a fellow in 2021. And Dr. Kolenikov has served on the organizing committees for both the 2018 and 2020 Big Surv conferences, and is on the committee for the upcoming 2023 conference as well. He has his PhD in statistics from the University of North Carolina, Chapel Hill. All right, Craig and Stas, I'm going to turn it on over to you.
Well, thanks very much, and welcome everybody. Thanks for joining us today, and thanks for having us, and thanks for the wonderful introductions there. I can skip my own self-introduction, so I'm going to try to make this fun and interactive as directed. So we're going to sort of speed through a set of slides here, and then hope to have some questions and answers afterwards. So did I advance the slides or no?
No.
There we go.
Yep.
So here's the cover of our book. We have several co-authors. Of course, Stas and I are here today, but we also have Paul Beamer, Trent Busker, Lily Jopek, Antje Kirchner, and the dearly departed Lars Leiberg, working all together to put this book together. And, you know, shameless plug here, it's available on Amazon. This is all I'm going to say, but and there are used copies available. You can even get a Kindle version. And as noted here, we were trying to, I'm going to tell a story in a second here, but as the slide says here, we were trying to help survey research and social science researchers navigate the big data ecosystem, which 5 years ago or so was starting to become a thing. And so it has a pretty wide purview. It contains what we thought of as groundbreaking survey methods being utilized today in big data, exploring how machine learning methods can be applied to design, collection, analysis of social science data. Has a lot of examples and illustrations that show you how survey data and approaches to generating survey data can benefit approaches used to working with big data. We have a lot of methods and applications in combining big data or administrative data with survey statistics. And we ended up with talking about regulations and other ethical and privacy issues as regarding the use of big data. In the introduction to the book, we tell a little bit of the story about what prompted the whole thing. So, as mentioned previously, we held the first Big Surf conference in 2018, but as you can imagine, we were planning for that well before that. And what we thought was going on was that big data was becoming a thing, as I mentioned, and there was worry on the part of some people, angst on the part of some people that big data and computer scientists were going to sort of run away with social science research and just apply big data to everything and replace survey research as we knew it. And so we had the idea that we wanted to form a big tent, essentially, and get computer scientists and social science researchers, survey researchers under that same tent to talk with each other and exchange ideas about the uses of data. Because as is noted here on the slide, I mean, we had the idea that survey researchers actually could be helpful to people who are working with big data because survey researchers have a lot of experience in designing the data collection process that provides context and answers how and why questions. And we have a lot of experience in cleaning data and making sure that data are reliable and valid and are of high quality. And we wanted to make sure that computer scientists were thinking about these kind of things as they were working with big data. So as we thought about the big data ecosystem, we wanted to make sure that there were both, as I say, social scientists and computer scientists thinking about it together. And so that was really the genesis for the book that came out of the conference. So this is just a screenshot from the bigsurf.org website, which talks a little bit about the 2018 conference that we had in Barcelona, where we did actually succeed in getting survey researchers, social scientists, and computer scientists under that same tent. And then, of course, like everyone else, we had a virtual conference in 2020 where we tried to continue on with that sort of messaging. And we'll say a little bit about this at the end, but we are now in the process of planning for 2023 conference. So I just wanted to add a couple of things about the introduction before we move on. That, as I said, when we first started, we really thought that, or as I say, there was a worry that big data was going to be kind of a one-way street, that that was just going to be applied to social science problems. But as we thought about it more and as we learned more, it actually was a two-way street where we could do a lot of exchange of information. And in the book, we define simply big data as non-sampled data or organic data, found data. And big can take on a variety of meanings for some of us. Some data are bigger than others, but we also make the point in the introduction that the types and sources of, quote, big data are many and varied, that it can, in fact, be used to help improve statistical estimates, but that there were challenges that exist 5 years ago, still exist today, including the identification and treatment of errors in big data, that there's not really a framework for uncertainty characterization and quantification, that there are issues with data provenance and ownership, issues of reproducibility, algorithmic bias, we've all seen evidence of that, And there are storage and processing issues, a whole set of governance issues around the use of big data. So I wanted to make all of these points in the introduction, which we did. And that came out of the conference as well. So now we're just going to walk through, the book has 6 sections, and we're going to kind of walk through the 6 sections in the book. We're not going to talk about every chapter. We'd be here all day if we did that, but going to talk about each of the 6 sections and then highlight one of the chapters in each of the 6 sections. So Stas is going to start with section 1.
Thank you, Craig. So the book opens with a section that looks at how the recent development in data sources and methods affect what can be considered traditional survey work, which is producing estimates of some quantities that are of interest to the public, or for instance, polling on social political issues, or of interest to the government, various aspects of economy, public health, stuff like that. So what's in this new survey landscape? Well, there are machine learning methods that supplement, replace, enhance the traditional statistical models, and that they can be used to run mostly automated tasks, find efficiencies in data collection, data processing. The new landscape includes the non-survey data sources, admin data, social media, data from sensors, transaction data, GPS tracking data, and other sources of that computational origin, Internet of Things origin. The new landscape of social research inevitably includes social media. We need to understand how that stuff works, if it works, and we end up usually comparing social media results with the survey data or other known quantities, and we need to think about problems such as multiple sources of data, multiple frame surveys, multiple mode surveys. And finally, even within the data, within the survey data collection efforts, some data can now be collected automatically, passively through the cell phones and sensors in the cell phones, and that's also part of the new landscape. Next slide. Why machines matter for survey and social science researchers. I'll talk about this chapter 1 of the book, and it also serves to recognize contributions of its authors to Big Sur of 18. So Antje Kirchner was the main organizer of the conference. She spent innumerable hours in running meetings, balancing the budget sheets, juggling who does what in the work committee, who contacts which sponsor, who reviews which set of submissions. So negotiating with Ezra, who was one of the organizers of the conference, talking with the local folks at University of PU Fabra, who were organizing the local events, reserving the rooms and whatnot. So that was truly hot conference. And Trent Basker was on the committee in the various review tasks and other organizational work. So chapter content. So Trent and Antje open up by observing that survey data getting bigger in their own right, namely getting wider. There are more variables collected, new forms of data such as passively collected sensor data, images of environment, images of food taken, which was an interesting AAPOR data challenge a few years ago. And so processing hundreds of variables, let alone tens of thousands of pixels in those images, that's way beyond what the human brain can do. That stuff has to be relegated to the machines. And that's what the machine learning methods offer and deliver. Those are flexible, non-parametric methods for making predictions or classification from data. So these methods detect and accommodate nonlinearities, interactions in automatic way. So for instance, classification regression trees build models based on splits by variable. So in the end, you have kind of piecewise rectangular simple models based on those rectangles and boxes in the predicted space. And random forests combine those individual trees to smooth the edges out. So nearly all machine learning parameters have, not all machine learning methods have some sort of tuning parameters. like step size and optimization, degree of complexity of the model, the strengths of interactions that are allowed. And so while humans can provide input as to what those parameters should be, this typically they are chosen by cross-validation, which a portion of the data set is set aside to feed the models, the training set. And another portion is used to provide an independent assessment of goodness of fit, the test set, and there are also validation. The third set may be a validation set to choose those tuning parameters. So Trent and I to talk about those general aspects of machine learning, and then they move on to talk about applications in the survey process. At the sampling design stage, they list applications such as unsupervised clustering to create sampling strata, frame construction from satellite images using machine learning models to predict eligibility in establishment surveys. They connect the errors intrinsic to machine learning models to the TSC framework, total survey errors, such as incorrect prediction of eligibility leads to undercoverage if that's a miss, or sampling inefficiency if that's a type 1 error. So, and VS in machine learning, they're typically treated as sort of equal, but for us as survey statisticians, undercoverage is probably much greater concern than losing another $10 on the contact attempt. So in the survey, in the section survey recruitment and data collection, they talk about interviewer monitoring, detection of performance issues, detection of interview falsification, use of machine learning in responsive adaptive designs to predict survey participation or longitudinal attrition. This data processing section on coding open-ended questions using natural language processing, imputation, record linkage, where machine learning can be used to assess the importance of variables for matching. This is weighting and estimation stuff. So that's existing interfaces with formal statistical literatures. So that's the first chapter. Back to you, Craig.
Thanks, Stas. So section 2, total error and data quality, focuses on errors that we find in administrative and other big data sources. So we've got a bunch of chapters in here that describe efforts to understand and quantify those errors and their effects on data quality and on some substantive conclusions that one might draw from using those kind of data sources. So let's dive a little bit deeper into one of these chapters, which is the first one here, chapter 4, which is Beamer and Amaya talking about total error frameworks for found data. This chapter focuses on the accuracy of data produced by integrating 2 or more data sets, especially when one data set is from a survey and another is, is for administrative purposes. So it goes on to describe the process of integrating and harmonizing data sets. There's a little workflow diagram that you can follow to make that happen. And they follow that by some examples of applying the total error framework, which I hope most of you are familiar with as it applies to survey data, to an integrated data set. So that is, how do you identify and quantify missing data or content error or specification error in that integrated data set? And okay, once you've identified those errors, well, how do you account for them or quantify them? If you like formulas, there's a lot of formulas in this particular chapter. So you can check that out, including you get formula for the components of bias, variance, and standard errors in these integrated data sets. One of the things I like best about this chapter is they provide an illustration of these concepts as applied to real world data. So for example, they ask, in the chapter, they ask, well, which do you think would be more accurate? An estimate of the population average based on an administrative data set with almost 100 million records and over 80% coverage, or a national survey estimate based upon a probability sample of 6,000 respondents with a 45% response rate. And then they go on to apply this to the residential energy consumption survey, which asks respondents to provide an estimate of the square footage of their home, and they compare that to the same estimates that you might get from Zillow and or from tax records. It's an interesting exercise, and I think and illustrates really well what you need to be taking into account when you're using an integrated data set. In the conclusion of this chapter, they note that we in the survey research field have to understand and recognize that hybrid estimation is the future, and that it's essential for us as researchers to enter this new era with a heightened awareness that data are inherently flawed, no matter where they come from, and you got to pay attention to that when you're using data from any source, really. Okay, Stas, I'm going to give it over back to you for section 3.
Right. So the next part of the book looks more specifically at how the national statistical offices utilize big data. So the chapters were contributed by methodologists from Statistics Sweden, Statistics Netherlands, Australian Bureau of Statistics, the US Census Bureau. So as this audience most likely knows, the US is fairly unique in having a distributed system of official statistics in which statistical agencies are units within their substantive departments. So the National Center for Health Statistics is a unit within the Department of Health and Human Services. I think it's layer 4 in HHS, and Census Bureau is a unit within Department of Commerce. Nearly everywhere else in the world, there is only one national statistical agency that collects and processes all the official statistics data. So they may have some advantages in being able to kind of focus their national resources on building expertise in big data. So national statistical offices around the world are exploring the various ways to utilize big data. I obviously was there at Big Sur of 18 in Barcelona, and I think the keynote presentation by Tom Smith, the director of the UK's Office of National Statistics Data Science Campus, that was a stunning presentation. I learned a hell of a lot from that. So he cited several examples of how the big data sources have been helping ONS or could be used potentially. So he talked about the use of GPS data from ocean ships or those sensors of ships currently in the sea. While this is necessary for navigation purposes and navigation safety, but this could also serve as a leading indicator of trade when you know that this ship is traveling from China to America or from Philippines to UK or whatever. He talked about the use of social media as an indicator for tourism. If you weren't there and you were not taking a picture, geotagging them and putting hashtags Barcelona 18, you were not there. I mean, nobody's going to believe that you were. So you need to scrape Instagram and Facebook and see what's happening there. He talked about using Google Street Views for various building enumeration tasks, urban vegetation enumeration tasks. So he talked about a big project that listed all the trees in London. And he talked about how to triangulate between sources. That's what Craig referred to earlier as hybrid estimation, where you need to talk about different things. So I'll focus on the chapter by Lily Japek and Lars Luberg. Again, those are contributors to the conference, the founding fathers of the series. They synthesized the experience across many statistical agencies, primarily across EU, but also internationally elsewhere. In the changing survey landscape section, they talked about the transition of official statistics through the survey paradigm. Well, in 1930s, you had to sell it. You had to say, okay, well, this guy, George Neyman, published those cool papers about stratified studies. And as a Russian, I would say, okay, well, there was some papers from 1921 by Russian statisticians that did the same, that were unknown in the West. We can talk about that history stuff. So we transitioned through acceptance of surveys as the de facto standard, and now we are moving on to big data. And Tom Smith went as far as to say that the service should be the last resort to tell us things we cannot find out otherwise and that we don't already know. And David Haziza and Jean-Francois Beaumont from Stats Canada said that surveys are dead. And so that's a part of Lily's and Lars' chapter that they talked about that sort of history. They identified the strategies that the national statistical agencies use to handle the new challenges. So be that training their staff internally, forming partnership with the researchers in universities, or large-scale opportunities with tech firms, and what kind of legal and ethical challenges those might present. Cooperation between organizations, cooperation between the national statistical agencies within the EU, cooperation between federal agencies in the US. Then they moved on to talk, well, when they talk about the quality issues, they reconnected with the TC framework as well as with the Paul Beamer's and Schlemeyer's chapter. They talked about the quality definitions, dimensions, a little bit kind of complementing that chapter. And interestingly, they pointed out the situations where the quality assessments have to go in reverse, right? So Craig talked about this impending doom feeling in 2010s that the big data is going to supplement everything. It turns out that, well, what they were doing is they were presenting cool big data science work and say, look, our price index tracks the BLS price index. Well, yeah, well, you have to look into something and you have to connect to the probability source to really say my stuff makes sense. And that's probably a little bit underappreciated. So they talked about legal issues, and Craig is going to talk more about that as a full standalone chapter. Stuff there is some unclear interpretations of privacy laws and how they can catch up with technological developments. If you've been doing phone service in the US, you know how strange the landscape is. There's statistical disclosure issues, and again, the US folks have seen the census saga going on with that. We were all very saddened by passing of Lars in March 2021. He is fondly remembered in the discipline as a wonderful colleague, as a mentor to many of us, and as a friend to many of us.
Yeah.
Craig? Mm-hmm.
Stas. So section 4 talks about combining big data with survey statistics and methods and applications we can use to do that. So the exponential growth of computing power and the availability of cheap data and cheap data storage have given rise to all these big data applications. This is what we saw back then 5 years ago, still true, including artificial intelligence and machine learning. And in this section, our authors investigated the potential of these applications and methods for survey research, and demonstrating, for example, how big data can be used to improve sampling efficiencies, or to complement or even replace survey data, as Stas was just referencing, or how machine learning, for example, can be used to improve the accuracy of estimates. So I'm going to talk a little bit more about this one, chapter 15, assessing community well-being using Google Street View and satellite image. And in this chapter, chapter 15, the authors propose a method, a model, essentially, to predict social well-being and health outcomes at the census tract level using a combination of Google Street View and Google Earth imagery, plus data from Burfus and from the Gallup Daily Tracking Survey. They combined all of those data sources together. And in short, they go through the methods here, but in short, they compiled a large set of images in both Baltimore and in San Francisco. Then they used Mechanical Turk to hire people to label those images according to whether the images contained features that were identified in previous literature as being predictive of social well-being and good health outcomes. I mentioned when I was talking before about a lot of formulas in the Beamer article. This article has no formulas, but it has a lot of pictures and really some really cool pictures of from Google Street View about where you can see graffiti and trash and broken windows, and because these are all indicators of social well-being when you see them in the pictures. And their conclusion is that the model they built seemed to explain a pretty significant amount of outcome variance, for example, explaining. Hey, Phil, you might want to mute yourself, please. Thank you. Explaining about 56% of variance on mental health in Baltimore. They do note, however, that there are a lot of limitations with this particular kind of approach. Crowdsourcing the image labeling work can be pretty fast, but it is quite labor intensive, and there are a lot of reliability issues that require a lot of QC in order to get that right. And they suggest a couple of other ways now that researchers might approach that kind of work. All right, I'm going to stop there and turn it over to Stas, who's going to talk about section 5.
Right. So I was the editor responsible for this portion of the book. So we had a team of co-editors, and each one was working on a particular chapter. So in this section, we highlighted the tools and applications that combine big data and survey statistics. David Dutwing contributed a chapter where he was looking at using the appended auxiliary demographic variables available from the marketing world, MSG and Dynata, to predict rare population characteristic. So I was fortunate to be able to tell off the AAPOR president, the VP, and say, get your SH stuff together. Deadline is coming. I'm not sure if we're gonna have opportunity like that again. So Steve Cohen and Jamie Shorey contributed a chapter where they described their work on comparing the imputation methods for large survey with a lot of skewed and weird data, lots of structural zeros, lots of outliers, the medical expenditure panel survey. They use traditional hot deck, which is the production method that's used on maps, and they were entertaining the idea of using machine learning methods to produce predictions for the multiple imputation way, with the promise of getting faster turnaround, requiring less professional time to really fiddle with everything. So that's, I think that was a useful chapter to see how that stuff may work in an applied setting. So the chapter that I am going to highlight and talk a little bit more about it came from a panel organized by Safa Amir, who led the chapter. She was at RTI, now she's at Facebook for a couple of years. So the panel looked at what's called the gridded populations, and that was the presentations by the providers. Dana Thompson from the World Pop Project at Southampton and Flow Miner Foundation in Sweden, Amy Rose of Oak Ridge National Lab, it's another provider of a gridded population product, and Safa was talking about RTI's work on setting up some international studies and running them using those gridded populations. So the gridded population is a synthetic population, set of tools based on GIS technology. It combines sources of demographic, economic data, satellite images, cell phone data, whatever you can find to come up with an idea of how many people populate a given square of 100 by 100 meters or kilometer by kilometer. So the world land mass is broken into those little cells, and the models try to come up with the numbers there. You can have top-down models where you models where you take the known census data and break this down in geographic regions and break this into districts and break this into the analogs of tracts if they exist in the administrative geography and go down to those cells. Or you can really go from the bottom up, starting with your pixels in satellite images and land scan, and classifying those images as residential, agricultural, no use, like mountains or whatever, vegetation, jungles, forests, and going up and trying to find people in those cells and figure out if those cells are populated. So the main interest of survey organizations in these tools is basically the sampling frame. Sometimes that's the only sampling frame available if the previous census was 3 decades ago. And that's unfortunately is the case in some of the African countries that have civil wars going for those 2 or 3 decades. My understanding is that currently, I'm not sure if that was at the time of writing that chapter, but currently most of that is sort of aggregated in the gridsample.rg website, where and they also have accompanying R and Python libraries, and they have interface with the those grid population models, WorldPop, Grid3, Landscan, HD. So the data processing, statistical challenges, obviously there's a non-obvious relations between the jagged geographic regions that the administrative divisions have and those nice little squares, 100 by 100. And those 100 by 100, kilometer by kilometer do not align because, well, the world kind of squeezes as you go up towards the poles. So there is conceptual mismatch because typically we are interested in residential population, people living in households, but those models typically provide synthetic average population. So for instance, people may be commuting to their respective downtowns to work and place their cell phone calls that we observe, or there's energy output and that is being registered by the satellites in specific spectrum. And but that's not your residential population. So then for some of the tasks you want to have like age, sex, population projections. If you're trying to build a survey of maternal health in the country, well, these tools usually don't provide stuff like that. In terms of sampling work, you also have the problem of random sample sizes when you sample those grids, and you need to rebalance your interviewer load somewhat differently. But again, if you're working with a country that doesn't have administrative data, that's probably your best resource. Okay, Craig, back to you.
Thanks, Stas. So section 6, we talk about the fourth paradigm: regulations, ethics, privacy. I'll say what the fourth paradigm is in just a second, but the premise of this section is that we might someday, I hope anyway, arrive at this idealized future state where data are shareable and discoverable and accessible by virtually connected communities of researchers. That's what the fourth paradigm is. And if so, we'll have to rework regulations and the culture surrounding data privacy and ethics. Increasingly, science is a team sport. That requires close collaboration across multiple institutions and multiple researchers in their data. And so how do we make that utopia a reality? So we have several chapters in this section that talk about reproducibility problems, about how people view or give consent to allow their data to be collected passively, and how people attitudes get formed about the use of their data. And the last section is the last chapter is a chapter that I wrote, so I'm going to talk about it a little bit more. So I mentioned the fourth paradigm this is a concept that I got enamored with more than 15 years ago or so. There was a Microsoft researcher who sadly passed away right after we had documented this, but he called the first paradigm the empirical paradigm. So if you think about sort of the history of science, you had empirical, where most science was observational. The second paradigm was the theoretical paradigm, where science as we sort of know it today, involving theory generation and then hypothesis testing to prove or disprove a theory. The third paradigm is computational, where you're now able to apply the power of big data and the power of computers to those data to test, to do the hypothesis testing. And the fourth paradigm, as I described before, would be a data-enabled or e-science kind of paradigm, where you've got global collaboration, you're using big data, terascale or petascale computing, high performance visualization that's supported by hardware, by software, by tools that are jointly developed by scientists and computer scientists. So as I said before, this sounds kind of utopian, and it's kind of maybe why I was attracted to it. It sounds almost like science fiction, but I really like that notion. I really hope we can get there. But I go on to write in the chapter that, look, well, we still have a lot of technical challenges to overcome before we can get there. There are things in the way. We talk about what's been referred to as the 4 V's of big data: the variety, the volume of data, the velocity with which data is produced nowadays, and the validity of those data. Another technical challenge is what I've heard referred to as the long tail. In other words, we're generating, petabytes of data every day. Who decides how that data gets stored, when it gets destroyed? Who makes that kind of decision, and how do you do it? If you work at a Large Hadron Collider, for example, they are producing petabytes of data every day, but they use less than 1% of it. Where does that other data go? And as I say, who makes decisions about how that's governed, when and if it gets deleted? And we've talked about this before as part of technical challenges. We still have a challenge with uncertainty characterization and quantification, still have a challenge with reproducibility, because a lot of big data that's produced is, if you take a time slice of it and do some work with it, and then if Stas takes a time slice of that same data, it's different data. So it makes reproducibility hard. And so I write that the solution to all of this is for us as social scientists to become data aware. Really need to think about these kind of governance and data lifecycle issues up front when you're planning a research project. And I write a little bit about how you can do that and what the steps might be. And I also note that, and you're starting to see this at many colleges and universities now, where we're training people to become people, no matter what discipline they're in, whether it's history or English or physics, to become more data aware and to be able to apply sort of data science techniques early on in their career. So people are being trained that way now. More people will be trained that way in the future. And of course, you can upskill yourself now to become a data aware social science researcher. So in conclusion, to us, as I hope you've gathered, we really hope that this collection of innovative methods and tools and approaches and examples showed a willingness for us as survey researchers, social science researchers, to improve and adapt and meet computer scientists where they were living. I'm gonna just also, Stas mentioned this at the beginning, Big Serve 23 is just around the corner, you might say. It is going to be in Quito, Ecuador. It will be in person. Well, that's the plan as of now anyway. Slated for the 26th and the 29th of October in 2023. It's hosted by the United Nations Association of Ecuador in partnership with the USFQ Data Science Institute at Universidad San Francisco de Quito. So we'll be putting out a call for submissions in early 2023. So Stas mentioned that he's part of the organizing committee and they're making plans for that now. And I just want to remind you that there is a website for Big Serve. It's bigserve.org. So you can check out all the news. You can see stuff from past conferences. That's all there at bigserve.org. So with that, thanks very much, everybody, for having us today. And turn it back to Martha, who I think is going to drive us forward in terms of questions, answers, discussion.
Yes, thank you so much for the presentation and walking us through the book. So now we're going to open it up for questions. So please feel free to turn on your cameras, raise your hand if you'd like to speak so that we're not all speaking over each other and we can call on you. And when you start, just please give your name and your affiliation and then ask your question. Also, do we have any questions for Craig and Stas and the other, actually some of the other editors are here too and authors. So.
While we're waiting, I will point out that we, Stas mentioned this, that we had several editors, each of whom was assigned a section, and that's a large part of the work involved in producing an edited volume is, as Stas mentioned, sort of shepherding all of your individual authors through the process, while of course reviewing their manuscripts and making them pretty and ready for publication.
Sarah, you had your hands up first. Go ahead.
Great, thanks. So I'm curious about the vision for the future that Craig had outlined, and how do you think that will sort of reshape the US federal statistical system?
Wow, that's a good question. And Stas, maybe you'll want to think about this or answer this because you've been thinking, I know a lot about the use of official statistics for, I mean, the use of big data for official statistics. And I'm aware that there are some experiments occurring in the US federal system, but we don't have some of the same advantages that some of the European nations do. Stas, do you want to add to that?
Well, I mean, my personal opinion is that the progress is slow because there are all the bureaucratic barriers for the agencies to exchange data. So when we approach our respondents and ask what their income was, they say, oh, I already told the government what my income was. That's why I collect taxes. If you only knew how much effort it takes to get access to the tax data from IRS, you wouldn't have said that. So there are good initiatives in building the national data center, but my understanding is that that stuff is still at the concept phase. It's not that we have this supercomputer sitting somewhere where the stuff is
I will add
already available.
Yeah.
So Craig redirected this to me. I'll redirect this to Barry. So Barry has his hand up, and maybe that's a good opportunity for him to say, well, in the Netherlands, this happens.
I will add, before you chime in, Barry, I will add that there is a federal data strategy that was put out by actually during the Obama administration, and many critics call it an unfunded mandate. But the idea is that all federal government agencies have a chief information officer and a plan.
Chief data officer, yeah.
Data officer and a plan for making their data accessible, findable, usable.
Right, and there's evidence commission. Evidence was that
evidence-based.
Yeah, so there's a commission under Bureau of Economic Analysis where a lot of those CDOs sit, and that's where the slow progress is happening.
Yeah, progress is
the trend.
Variable.
That kind of Nick Hart's world. I don't know if Nick Hart is on this call. It would be great if he were. Okay, Barry.
Hi, afternoon. It's actually evening over here. So thanks for the, I'm Barry Schouten from Statistics Netherlands, as Craig, as Stas already said. So thanks for the introduction to the book. I I still really regret I wasn't in Barcelona, actually. I'm ashamed to say this, but I wasn't. Yeah, you were talking about the data strategy. So I think most statistical institutes have a strategy that they need to use data that's existent if it's sufficient quality. And that's where the complication comes, of course. So I have another question. So at Statistics Netherlands, big data was very, very big, maybe 5-6 years ago. And it backfired a little bit. Now it's more the hybrid version. So we're now more in the version where we would still combine surveys with big data. So we ask a person or a company, please give us your data. So we try to, we talk about things like data donation, going through the app to, let's say, external databases and all these kind of things. So I was wondering how you see this development, if you see it as a separate avenue, or, you know, is it, how do you feel about this?
Yeah, I mean, I agree with what should be in the future, at least the future as far as I can see, because while there are lots of big data sources available and administrative sources, and you should talk a little bit more about the backfiring in the Netherlands, Barry, but you can get a sense of directionality of change, for example, but not precise enough estimates so far for official statistics use. And so it's going to have to continue to be supplemented by, it seems to me, survey research for the foreseeable future. When you need that context about the why, you know, for some estimates, that still has to occur, it seems, at least for now. That's where we seem to be. Well, why did it backfire in the Netherlands, Barry?
I think most of the partners we worked with were not, I would say, reliable enough. They would either change data, or they would not deliver at some point, or they would just stop. You know, it's there were a few projects where they invested years, and then at the end, let's say the data holder said, no, we're not going to do this. So that it's not because of the data itself, but because of the reliability, I guess.
Yeah, you've got errors and you've got flaws in those data because they're found data, really not necessarily collected for the purpose that we need them. But
great. And we have time for just one more quick question. So go ahead.
Oh, is it me?
yeah.
Hi. Thank you so much. Quickly, really congratulations on the book. I've read so many times, for examples, case studies, trying to integrate into our position paper. So it's still open for comments. I've put the link there. I have two questions, if it's okay. One is there's this European trusted smart statistics and framework that just started, and there was a lot of discussion about this interlayer of data processing that will make it possible for all data users without having access to all these nano data or micro data from the private sector. Just look here, I would like to hear a few reflections from the authors and editors. The other question is in terms of using for National Statistical Office, especially developing countries. So we've been working with Colombia, and then what they did is they do the web scrape. So they scrape the data from Facebook, and they're trying to come up with some indicator on discriminations in the country. This is one of the SD indicators, and they would like to have more frequent data. But of course, as everybody knows, with the bias, it comes with a huge bias, and they also understand that. The things now, they're reaching out to us for benchmarking, but if you look at data, there's no social demographic characteristics, and Facebook would not give them any data because of the sensitivity. It's election time in Colombia, so they do not want to get involved, and there's nothing to benchmark on. And so there is a probabilistic survey in the country that can be used, but we just still like struggling. We don't know how to do it. So if you can give us any guidance, and that would be fantastic. Thank you.
I wish I could solve that problem, but it is a problem that exists, and it's a really good example of some of the issues we find with social media data. It's maybe you can try to apply the total error framework to this to try to get a handle on it, but And I know, for example, I don't know if anyone on here might be able to speak to this more than I could, but there is this effort by Social Science One to work with Facebook to get some of that sort of data behind the data or metadata, but I think that's sort of fallen apart and not fulfilled its promise. So I don't have
that's my impression too. Yeah, it's been kind of on and off. So you see all this, yeah, we're using Facebook, and then okay, well, and then you hear a researcher who's on this Social Science One and say, I couldn't really get any Facebook data for real. And what Bear alluded to is that there is all this excitement about using all those big data sources until the format of the HTML page changes and your web scraping code stops working. Or your API, the API is discontinued and you have no data at all. And that's, well, I mean, we want the data to be predictable and have no qualities, but that's just not how that world operates, right? So sometimes you can go to the archive.org to get historical static pages, but in terms of dynamically generated pages that are responding with underlying database queries, that's not an option. So it's a little bit of Wild West. That's my gut feeling. I mean, maybe one day we'll have a more consistent framework. But again, another thing that Bear alluded to is kind of voluntary agreements between governments and private sector companies in what they would be providing and how stable their data might be. I don't think that US has leverage over Google in that regard.
No, I mean, it's a large example of why we haven't reached the utopia that I was describing before, because there's so much data that is in private hands that we're unable to get.
Yeah, right. And my understanding is that in year 2010, 10% of the data were public and 90% were behind passwords and paywalls and VPNs. And these days it's probably 0.1% of internet is public and 99.9 is behind something. So it's has to be between bagged and mined and purchased. It's a lot of lift.
It's like a big challenge, and unfortunately it sounds like there's not an easy solution right now. So I do want to thank Craig and Stas again for their wonderful presentation and answering these questions, and thank you all for attending our event today. So just real quick, the book winner for this session is the DC-AAPOR member Jake Sofronoff. So we'll be in touch with you shortly about that. I also wanted to give you all a heads up that the next book club meeting will be on June 15th with Barry Schoten, as well as his co-authors for their book, Mixed Mode Official Surveys, Design and Analysis. So, hey, there might be some more of this big data meets survey data talk. You can sign up on our Eventbrite page, sorry. And before you leave, we do ask that you take just 90 seconds out of your afternoon and provide us a little bit of feedback. So I just sent, I just sent a link to the Google form, just 3 simple questions about how these sessions are going and anything you'd like to change. So that is all. I'll also send that out as an email in case you forget to click the form. But thank you all again, and I hope you all have a wonderful afternoon.
Thanks, everybody.
Thanks. Bye.